This is Frank Pace, Jr., chairman of the board.
One of the requirements of a great corporation is to command the respect and enthusiasm of its employees. To do this, the employees have to understand not only the purpose, but some of the problems and products of a corporation. In the case of General Dynamics, this is very difficult to portray because we have over 100,000 employees. We stretch the length and breadth of this land and all around the world. In an effort to make clear to our employees what we are trying to do, we have generated here a 30-minute film. Now, no 30-minute film can ever tell the story of General Dynamics, so there will be follow-on films. But this one will give you a beginning of an understanding of the total requirements of General Dynamics. Now, just over my shoulder is the new General Dynamics building in Rockefeller Center in the heart of New York City. This is another means of identifying and personalizing General Dynamics. So when you come to New York, you come to the General Dynamics building. I hope by the time you have seen the story that follows in this film, you will have a better understanding of General Dynamics as a whole and what we are trying to accomplish.
Within these walls at the John J. Hopkins Laboratory in San Diego are some of the greatest minds of our time. From here have already come such peaceful uses of nuclear energy as the Triga reactors for research and training, and the high-temperature gas-cooled reactor for power generation. Today, one of the most exciting areas of activity at the General Atomic Division is the direct conversion of nuclear heat to electricity. Here in the Direct Conversion Laboratory, scientists prepare to test new models of tiny devices to operate inside a high-temperature reactor. Here, the electron emitter for an experimental cesium cell direct conversion device is actually being tested. The trace on the oscilloscope shows the electric output characteristics of the laboratory device under study. This program is being carried on with support from the Rocky Mountain Pacific Nuclear Research Group of electric utility companies and the San Diego Gas and Electric Company. Its successful development might well revolutionize the electric power industry. In another laboratory, experiments are conducted to select durable and efficient materials to be used in other laboratory models of direct conversion devices now in the design stage. A sample material is placed in a vacuum chamber. A voltmeter measures electron activity as the emitter material is heated to about 1800 degrees centigrade. The temperature is determined by observing the brightness. A hot press, using hydraulic pressure and extremely high temperatures, is utilized to form new high-temperature components. In this case, powdered uranium carbide and zirconium carbide. As temperature and pressure increase, the sample goes from red to white heat. From tests currently underway at General Atomic, scientists anticipate dramatic increases in working efficiencies of direct conversion devices in the near future. In another experiment, the rate at which tested materials vaporize at very high temperatures is checked. Metallurgists constantly test new candidates searching for the answers that will one day make direct conversion systems competitive with the best power generating systems now in use. Following fabrication and testing, a new emitter sample is installed in an operating cesium cell device. Important as this program is, direct conversion of nuclear heat to electricity is only one of the fields in which General Atomic is working to help meet our energy needs in the years ahead. The Electrodynamic Division, which has long played an important role in supplying electric motors for industrial, marine, and Navy markets, where dependability is a vital factor, is also deeply in the space-age market, making large motors for use at intercontinental ballistic missile bases around the country. A rigorous quality control program at the Bayonne plant is paying off in many areas, notably in getting contracts from the Navy to supply motors for vessels such as submarines, which have very rigid sound and vibration control. Benefits of the quality control program are passed along to other customers. A vital part of this program is the division's laboratory for testing all incoming materials, including wire, flat insulation, and electrical steel, which are tested on a battery of specialized equipment unmatched by any other electric motor manufacturer. Typical is this precision testing machine, known as an endurometer, installed to grade the quality of ball bearings. Since it was installed, electric motors shipped from the Bayonne plant meet the most exacting requirements of the Navy for super quiet, vibration-free operation. Bearings and insulation materials that meet these rigid standards assure electrodynamic customers of quality and reliability in motors and generators for all applications. At Canadair, our major program neared completion as the last of an order of 33 CL-28 Argus submarine hunter-killer aircraft was rolled out of the construction hangar and readied for flight testing. The CL-28 was most significant in Canadair's construction program, for it was the first contract for a series of aircraft that was to result in today's Canadair 44 cargo airplane. Results with the Argus have been most satisfactory, and exercises with both the British and United States Navies, as well as with Canadian units, the aircraft has given a good account of itself. This little jet beauty is the pet of everyone at the Montreal plant. Trim, slim, and nimble, the CL-41 was designed at Canadair as a side-by-side trainer, capable of covering the full span of student training from primary through advanced instruction. The CL-41 has a highly efficient light alloy structure, and this, combined with a very light engine, means that the aircraft is a more rugged, economical, and efficient trainer than has been possible before. The CL-41 handles beautifully, has a T-tail that is ideal for aerobatics, and also makes for good spin recovery. Top speed in level flight is about 475 miles per hour. Her Pratt & Whitney JT-12 engine gives her plenty of reserve power for takeoffs and smooth landings. Deliveries of the first CL-44 troop and cargo planes to the Royal Canadian Air Force have begun. The military CL-44 is the same aircraft as the commercial Canadair 44, except that the military version has a large conventional side-loading cargo door instead of a swing tail. The 44 can get into and out of most existing airports at maximum gross weight, thanks to the performance of a Rolls-Royce engines. Noise levels of the aircraft on takeoff are below those of many piston aircraft. The powerful Tyne engines quickly take her to her best operating altitude of 15 to 20,000 feet. Canadair designers feel that the turboprop freighter has many advantages of economy and flexibility to recommend it. It can haul freight at 3.5 cents a ton mile. and is capable of cruising at 400 miles per hour. The first swing-tail version of the 44 was rolled out of the construction hangar at Montreal on August 25th. To the already low operating cost, the hinge-tail design adds a high degree of flexibility and efficiency in loading and unloading cargo. Orders for the plane have been placed by 3 United States all-cargo airlines, who have called the 44 the breakthrough that marks the real beginning of the air freight business. And Earl D. Johnson, president, Frank Pace Jr., chairman of General Dynamics, and Jeffrey Notman, president of Canadair Limited, agree fully. Canadair traffic experts say that no equipment now flying in the all-cargo trade will be able to compete with the 44 when it enters scheduled service next year. Scorpion, newest of the Navy's attack submarines and the 8th nuclear sub built by the Electric Boat Division, backs away from her fitting out pier for her maiden sea trials. Second ship of the Skipjack class, Scorpion is built especially for underwater speed and maneuverability. Electric Boat is building 3 more attack subs of the new Thresher class, Flasher, Greenling, and Gato. Other construction work at Electric Boat includes the killer submarine Tullabee, now nearing completion, and various stages of progress on 4 Polaris-firing fleet ballistic missile submarines. On her maiden trials, Scorpion stayed at sea for 37 hours and made several dives. Vice Admiral Hyman G. Rickover, who was embarked on the test run, said the ship's performance had been outstanding. He also had words of praise for the ship's crew and for her skipper, Commander Norman B. Bessack of Vallejo, California. Although the exact figures are secret, the Navy says that Skipjack is its fastest sub. Presumably, her sister ship Scorpion will match or beat some of those unofficial records. Just a month later, trials successfully behind her, Scorpion is dressed in holiday bunting for commissioning ceremonies. After today, she's a member of the United States Fleet and entitled to be called USS Scorpion. Distinguished visitors and the ship's officers come aboard for the dockside ceremony. On commissioning day, the ship's builder is the father of the bride. His job is to give the boat away. Scorpion's new commissioning pennant is temporarily displaced by the personal flag of Rear Admiral Lawrence R. Daspit, commander of Submarines Atlantic. Guest of honor, Rear Admiral Ramage told the audience this July was the greatest month in submarine history. At Cape Canaveral earlier in the month, the George Washington became the first submarine to fire a missile from underneath the ocean. Emerging at an angle of about 15 degrees, the Polaris missile quickly righted itself, then flew unerringly down the 1,100-mile range to its target in the South Atlantic. After a relatively short wait of 3 hours, a second Polaris is fired. This time, the missile emerges cleanly, ignites on schedule, and makes an arrow-straight flight. Inside George Washington, nothing was heard of the departing missiles except a slight bump when the missile rushed out. The second missile, like the first, ran straight and true all the way down her 1,000-mile-plus range. One major military program now being carried out at Stromberg-Carlson's Electronics Center near the northern edge of Rochester is the Area Communication System for the Army Signal Corps. Present contract for this equipment is for 1,503 units. 29 different types of units are needed by the Army. Interiors include telegraphic, telephonic, switching, and visual observation functions in a battle zone. All are self-contained and readily portable by truck or helicopter for a quick drop into battle areas. Underwater sound transmission and target classification is carried out at Stromberg's large sonar tank facility. Various Navy programs are being carried out in the tank facility. Work on non-acoustic submarine detection through study of surface phenomena and electromagnetic techniques is also underway at the facility. The Electronic Division's engineering department is also making use of the tank in the development of actual sonar hardware. As production of various pieces of equipment progresses, the tank will also serve as a quality control facility. Stromberg-Carlson's main plant on Carlson Road in Rochester is the center of the division's telephone manufacturing activity. On the line right now is Stromberg's popular new design called the Petite. This line turns out, tests, and ships 800 of the Petite model phone sets a day. Public response to the new design, which is extremely compact and light in weight, caused initial production plans to be increased by 50%. Sales have already absorbed the increased production run. The Petite is already installed in or going to over 2,000 communities, spread from Ocala, Florida to Kotzebue, Alaska, which boasts the only commercial telephone system north of the Arctic Circle. The brightly colored little telephone that lights up looks as if it will be a sales booster for the telephone division for some time to come. Liquid carbonic, the most international of General Dynamics divisions, with agencies and subsidiaries throughout the Western Hemisphere, is headquartered in Chicago. The division produces many industrial and medical gases, but its largest single product is carbon dioxide, either in liquid form or as solid dry ice. In fact, liquid carbonic is the world's largest producer of this versatile gas, used in hundreds of applications from the preservation of foods to the quick drying of foundry molds. The first step in carbon dioxide manufacturing is capturing flue gases from a boiler. The gases are then diverted to absorption towers, where the carbon dioxide is separated from other gases. The gas is then routed to compressors, where it is put under extreme pressure and greatly concentrated. In the compression process, the carbon dioxide has been reduced to a liquid. To make dry ice, the liquid gas is shot into an automatic press in the form of carbon dioxide snow. The press squeezes it into big snowballs in the form of blocks of CO2. Then it's cut and wrapped automatically and whisked off to waiting customers. Today, however, More CO2 is shipped in the form of a low-pressure liquid. For customers who want their carbon dioxide in this form, liquid carbonic makes the tanks, some 2,000 of which are spotted around the Chicago area alone. At Convair, San Diego, 880 aircraft are coming off the production line at the rate of about 6 a month. Interspersed on the same production line are 4 Convair 600 aircraft. Trans-World Airlines and Delta Airlines, which placed the original orders for the 880 back in 1956, will get the results of the initial production run. The 880 received its airworthiness certificate from the Federal Aviation Agency May 1st of this year, after a 16-month Convair FAA flight test program. Delta 880s now serve New York, Chicago, Atlanta, Memphis, Dallas, and Houston, with more cities scheduled to join the list as soon as the line takes delivery on additional aircraft it has ordered. Other airlines ordering either the 880 or the slightly larger and faster 600 include Civil Air Transport of China, Avenza, Japan Airlines, American Airlines, Swiss Air, Scandinavian Airline System, Real of Brazil, and Alaska Airlines. At the Convair Astronautics plant on Kearny Mesa in San Diego, construction work began early this year on the first Centaur space vehicle. Fabrication takes place in the same high bay area in which Atlas is built. In fact, some 80% of the equipment used to build Centaur is Atlas production tooling. The Centaur tank begins with this roll of light gauge steel. Steel used throughout the tank is thinner than a dime, ranging in thickness from 10 to 23 thousandths of an inch. Bulkheads for Centaur tanks begin on this radial stretch former, which forms the sections called gores. After trimming, the gores are butt welded by heliarc torch. Powered by a mixture of liquid hydrogen and liquid oxygen, Centaur will provide the United States with its most powerful research rocket yet, and will open the entire inner solar system to research. This is the Space Systems Launch Complex, Pad 16 at Cape Canaveral, from which Centaur will make its first flight during 1961. Walls of the blockhouse are of concrete, from 6 to 15 feet, covered by 10 feet of sand. The complex is scheduled to be ready for use before the beginning of 1961. As construction progressed on Centaur's test and launch stands, final fabrication was beginning on the first flight vehicle. Here in the final assembly dock, all electronic, electrical, and mechanical systems, including engines, will be mounted on the first Centaur, scheduled for first flight in June 1961. At Fort Worth, Texas, Convair is producing the world's fastest bomber, the Air Force B-58 Hustler. This sleekly triangular weapon system delivers a nuclear knockout with pinpoint accuracy at twice the speed of sound. Navigational and radar bombing systems are so advanced, the Hustler needs only a crew of 3. Extra fuel for longer range and the nuclear warhead are housed within the disposable armament pod the Hustler carries beneath its slender body. The Hustler not only flies at stratospheric altitudes, well out of enemy reach, but also can sneak in under enemy radar, a few hundred feet off the ground. As it phases into the operational inventory, the men of the 43rd Bomb Wing at Carswell Air Force Base are for the first time giving America's Strategic Air Command a supersonic deterrent capability, a new flexibility in our manned weapons for peace. From Convair, Pomona, another installation devoted exclusively to missiles, come the Navy missiles Terrier and Tartar. At a land-based test center, an advanced Terrier is put through its paces as the Navy's newest anti-aircraft missile. Advanced Terrier has a lethal reach of more than 10 miles, far superior to 5-inch guns. From the launcher, a salvo of solid-fuel advanced Terriers head for their target riding an invisible radar beam. With surface-to-surface as well as surface-to-air capability, Advanced Terrier will also be used by the Marine Corps for amphibious operations. Aboard the USS Norton Sound, Navy guided missile test ship, crewmen prepare for a launching of a Tartar anti-aircraft missile. Here, crewmen wheel a Tartar to the launcher by hand. In actual operation, it will be loaded automatically. About half the size of the original Terrier, the compact Tartar will stand most of its sea duty on destroyers, such as the USS Charles F. Adams, recently commissioned as the Navy's first Tartar ship. Tartar also follows a supersonic course, guided unerringly to a barely visible target by radar. Hit. One important source of raw materials for material surface is its vast limestone quarry at Thornton, Illinois. This is the largest of 5 owned by the division, 1,300 acres in area. About 500 acres are now being worked. Thornton Quarry has been in operation for about 80 years. It is estimated that enough stone remains for another 100 years of quarrying. Things are done on a big scale here. In blasting every second or third day, 30 to 35,000 tons of stone are taken down. These trucks carry up to 53 tons of stone. Big John can pick up 11 cubic yards or 13 tons at a bite. More than 50 different sizes or combinations of stone, ranging from 6-inch chunks to powder-fine dust, are shipped to meet the specifications of the customers in the 3-state areas served by the Thornton Quarry. This 54-inch gyratory crusher was recently installed at a cost of $500,000. A new conveyor system now being erected will carry the crushed stone to various stockpiles and loading facilities. Total length of the complete system will be about 800 feet. An average day shipment runs about 1,200 truckloads and 100 carloads, a daily total of about 26,000 tons. Annual production runs from 4 to 6 million tons. A building boom involving hundreds of buildings, miles of roadway, changing the face of downtown Chicago, and Material Service Yard 1 on the Chicago River is supplying a lot of the concrete for the facelifting. Actually, Yard 1 is 5 separate concrete plants at one address. Capacity of the yard is more than 500 cubic yards of concrete per hour. To keep up with the constantly growing demand for more and more concrete, automation has been introduced into the construction business. The plant operator, who has the order for each truck, inserts a punch card into his control panel, pushes a button, and the proper combination of cement, sand, gravel, and water goes into the truck for delivery. Material Service can provide the customer, at the lowest possible price, the best possible service. Service unmatched by any competitor. Constant control is kept on the fleet, and the dispatcher is able to direct traffic for peak efficiency. On a normal day, 40 to 45 trucks operate out of the yard. Even this capacity is not enough, however, to handle the demand for concrete in the loop area served by Yard 1, and the adjoining block square property was recently acquired for expansion of the yard's facilities. The largest General Dynamics Division Navy is owned by Material Service, which operates 90 barges, 5 towboats. The Marine Department is responsible for keeping most of Material Service's 35 distribution plants around the Chicago area supplied with sand, gravel, and stone. The fleet moves some 4 million tons a year of the division's own supplies, acts as a towing contractor for other companies, moving an additional 1 million tons of grain, gasoline, coal, and other commodities for other companies. Because Material Service feels that emergencies are our business, all towboats, as well as the ready-mix trucks and the automobiles of supervisors, are equipped with two-way radios. The company operates 2 transmitters, which permit it to get in touch with any of its radio units, any hour of the day or night. Material Service barges don't waste any time waiting around for drawbridges to open. All are equipped with retractable pilot houses that can duck down onto the numerous automobile bridges around Chicago. Here and in all divisions of General Dynamics, massive applications of capital have purchased for us the most modern equipment and enable us to supply the customer with the best service in the world.